Introducing Scrat, a robot created in SOLIDWORKS and meant to portray a quadruped that looks and moves naturally. The legs are overdefined with 8 DOFs in each of the back legs, 7 in each of the front, with 30 DOFs in total. Let's explore 2 areas with Scrat, walking and singularity detection.
As you can see, we have a very natural motion for Scrat walking. By splitting motion into planar and normal components, we create a general gait that is applied to each leg with a phase shift. Now, let's explore what happens when we reach the end of our joint ranges, singularity.
You can see that we managed to get the robot to sway for a bit. We did this by moving the robot at some x of t and moving the legs at negative x of t. However, when we hit a singularity, outside the task space, we run into a pretty crazy error. Let's fix this with a weighted pseudo-inverse.
We can now see that the legs are less frantic. Let us now go through how to prevent Scrat from becoming a flying squirrel. To detect a singularity, we recognize that with our weighted pseudo-inverse, once a singularity is reached in a leg, it will start to drag as it is no longer able to follow the desired position generated from our walking gait. So, a singularity can be detected and avoided simply by predicting when this drag will occur.
When we predict a singularity, we can now move our legs, taking the walking gait, to get back within our workspace. We can now see why overactuated legs are great. They let us keep our feet flat, even when approaching singularities.
As you might have noticed in the last demo, the knee got quite a bit under the robot. We can add in a secondary task to center the legs at some predetermined position. While this effect isn't very strong, it helps the legs stay near their original position.
By moving the torso up and down, we can also maneuver while crouched or perform push-ups.
When we combine everything, we can get some very interesting motions.